So setup. Let's go through the basics again. You need to know the pitch of your threaded rod. In this case it's 1.5 millimeters, and you need to know the kerf of your blade, and in this case it's 2.8 millimeters. And whilst we're raising the blade, let's also set its height. These two workpieces are going to be the same thickness, and you want your blade just a little bit taller than the workpiece, because you can trim off excess fingers quite easily, but filling gaps isn't so easy. Now, one jump of the carriage will move my blade 1.5 millimeters. So I could take a cut, move the carriage one pitch, take another cut, or I could try, make a cut, move the carriage 2 pitches, which is 3 millimeters, and make another cut, and see if the blade wobble left a sliver between the 2 cuts or not. And my experience is that it doesn't. So I can jump 2 threads at a time. If it were the case that those 2 cuts did leave a sliver in the middle, well then I could just jump 1 thread at a time and I'd have a very clean top to the cut. If I had a 1.25 millimeter pitch thread, which would perhaps have been slightly better, then 2 jumps of the thread would be 2.5 millimeters, and then with a 2.8 millimeter blade there definitely would not have been any slivers in between the cuts.
Now the size of the gap and the size of the finger are not going to be the same. The gap will be slightly bigger than the finger. But if you use the jig in the simplest way, the way that I'm intending, then what you could call the repeating unit, or if you're of a scientific frame of mind, the wavelength, will always be the same and will be fixed by the pitch of the thread. And the repeating unit is 1 finger plus 1 gap. Now the smallest you can go is limited by the kerf of the blade. And with the setup I've been describing, you can't get under 6 millimeters repeating unit. But above that, the repeating unit can be any even multiple of the pitch, in this case 3 millimeters. So I could go up to a repeating unit of 9 millimeters, 12 millimeters, 15 millimeters, and so on. It's not infinitely variable. If you wanted to have evenly sized, evenly spaced fingers all the way across a piece of arbitrary dimension, you might not be able to do it with this jig. So let's go through a couple of examples. First of all, the test cut I did at the end of the previous video on the construction of the jig. I wanted fingers that were about 6 millimeters, around 1/4 of an inch. That would be a repeating unit or wavelength of 12 millimeters, which is 8 thread jumps on this 1.5 millimeter pitch thread. Now, as we've said many times, the kerf of my blade is 2.8 millimeters. So when you add up a kerf plus 2 jumps, you get 5.8 millimeters. So I need to adjust the last cut to be a little bit bigger. I need to adjust it to be theoretically 0.2. What works out nicely is 0.3 bigger, and that turns out to be about 70 degrees turn from, if you like, PM to AM on the handle here. You go anti-clockwise or counterclockwise because you're pushing the nut down the thread. If the nut were fixed, the thread would be backing out. You'll see there are 2 boards there. I'm going to cut both halves of the joint at once. You don't need to stagger them like that if your workpiece dimension is an exact multiple of the repeating unit or wavelength. But if your workpiece dimension is a multiple of the repeating unit plus approximately a finger, then you do need to stagger the boards like that if you're going to cut them both at once. But for the detail of that consideration, I'll refer you to the website article mentioned in the description down below. So I make a cut, then I jump the carriage by 2 threads. I move the handle / pointer from about 1:30 to about 10:30, from PM to AM if you like, and I make another cut. And then I jump the carriage by 6 threads and start again. Now, moving 2 threads per cut works in this particular example. There's a chance though it could leave a sliver between the 2 cuts, in which case you could make a cut, jump 1 thread, make another cut, jump another thread, and then move the handle and make the last cut. Let's take another example. Say you did have a threaded rod where the thread pitch was 1.25 millimeters, and again you wanted to do something where the fingers were around a quarter of an inch, 6 point something millimeters. Well, if you take 10 threads, you've got a repeating unit of 12.5 millimeters, so that's about right for one finger and one gap. And if you have a look at what the gap is actually going to be, that would be 2.8 plus 3.75. That's 3 thread pitches plus the kerf of the blade, and 6.55 is what results, and that's of course too big. So this time you would go the other way. You would start with your pointer over on the AM side, and on the last cut you would pop it over to here to reduce the width of the cut, and then for the next start, having jumped an appropriate number of threads, you'd be back over there again.
Now, the original impetus for all this was one rather large right-angled joint that's going to be used to adapt my engineering vise to sit in my woodworking vise without having to unscrew and screw the darn thing all the time. So let's go through some possibly unnecessarily detailed calculations as to how we might cut this by way of illustration. We have a dimension here of 164 millimeters. This will be trimmed down to that. How might we cut that? Using our 1.5 pitch threaded rod. Well, we could try a repeating unit of 24 millimeters, that's 16 threads. 164 divided by 24 gives 6.8, and that's not a particularly handy number of repeating units. What about one down from that? 164 divided by 14 threads, or 21 millimeters, gives a repeating unit sized 7.8, and that's not particularly handy either. Going one up, that is a repeating unit of 27 millimeters, and that gives 6, which is just about what we want. 6 repeating units. A possibility would have been that we came up with something and a half, and that would have meant we could have used a bunch of repeating units plus one more finger. But we can have an even number of repeating units, and that means we could theoretically cut both boards at once and not bother to have to do an offset here. When you've got an exact number of repeating units, you can cut both boards flush like that and simply turn one of them round. It's this situation here. You've got an even number of repeating units. The outside finger at one end will be on one piece, the outside finger at the other end will be on the other piece. And you can cut them flush and simply turn them round. If it had worked out that we had an even number of repeating units and a finger, then it would have been this kind of pattern here. The outside finger on each end would have come from one workpiece, and that's the time at which you do an offset like that if you're going to cut both pieces together. However, it would be a bit crazy to try and cut both of these together. They're rather thick. Whenever you're doing a blind cut, that is a cut when the blade is not protruding through the workpiece but is instead buried inside the workpiece, you have a problem with clearing sawdust and with getting enough air through there for cooling, especially in this piece here, which is going to be a rip cut. This will be easier, this will be a cross cut, and when you're using a general purpose blade, you tend to have slightly too many teeth for a rip cut and slightly too few teeth for a cross cut. But that also adds in this piece here difficulties to the clearance of the sawdust and thus the build-up of heat. So I'll be cutting them one at a time. And incidentally, the reason for hovering around a repeating unit of 24 millimeters rather than the 12-ish that we had previously is that I want to have fingers of approximately ½ an inch or 12 millimeters rather than the thinner fingers of before, simply because thinner fingers is more glue up. I'll cut this longer piece first for reasons which you may guess at if you've seen the update and which will become apparent later. They're not quite the same thickness, so I'll set the blade on the thickness of this other piece here, and as we've said, you want it to be just a little bit taller. I've used the T-track on the rip fence to set up a better stop here. There's no point in the crosscut sled being able to travel any further forward than it needs. The next thing to consider is the order of the cuts. Because this is the rip cut, I won't be trying to do 2 thread advances and then cut. I'll just do 1 thread jump and cut. There are 7 advances to cut out the gap and then another 11 advances to create the finger. So that's going to be cut, jump, 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 adjust pointer, 1 more cut and then jump 11. So we chose a repeating unit or wavelength of 27mm and got 6 repeating units out of it. This workpiece was 164 across. If you multiply 27 by 6 you get 162, so there's 2mm to be trimmed off the edge here, which I shall do later. That was that part of my rather strange one-off joint for my vice adapter. Now we come to the second part, the bit that actually sits in the jaws of the woodworking vice. And we encounter a possible limitation with this approach, which is clamping. We need to clamp the workpiece to the jig fence. It's no good clamping it to the crosscut fence because we can't move the jig. Now that's fine when you have a tall workpiece, but it's not good when you have a short workpiece. So what can we do about it? Well, there's a couple of possibilities, at the very least. The first one is to use a sacrificial fence, which you might do anyway. It helps prevent chip out or tear out. And we can hot melt glue the workpiece to the sacrificial fence and then clamp the sacrificial fence to the jig fence. And that's what I'm going to do for this piece. If you had several pieces you were going to cut at once, then hot melt glue and a sacrificial fence becomes less feasible. So the second possibility is to add a T-track to the fence here. And when I remake this fence, I'm going to put the T-track here and use the screws that hold the T-track in to also hold the fence to the moving carriage. And another possibility is that we do start using a side fence. And then you can have more T-track coming along the side fence. And with those two possibilities, a toggle clamp can go into the T-track and clamp down at any point you like, or can go into the track on the side fence here and clamp down at any point you like. And we'll be exploring adding a T-track and a toggle clamp in part 3 of this series.
One of the things you have to bear in mind when using a system that jumps, like the peg system or this system, is the accumulation of sawdust under the workpiece, and in this case under the jig fence. If you've got good dust extraction around the blade box of your table saw, it shouldn't be quite so much of a problem, otherwise you're going to have to clear the dust occasionally. If you don't, the fingers will be of uneven height, and in this jig you will introduce some slack between the threaded rod and the half nut, and so you'll also have variation in the width of the gaps as well.
Well, it's only my 4th box joint and I lost count. I'm going to have to put a fillet in there. Otherwise, not too bad.